I recently built this table that can draw on the sand, and it's pretty cool. Now it's rectangular in shape, and rectangular in shape means that it's good for drawing rectangles. But what happens if you want to make a circle design? So that's why I'm gonna do is try to figure out how to make a circular table. Now I want to be able to cut when using a laser cutter instead of 3D printing, which is slow. And I want make them small in design so that my students could build one as well. And so now I'm in this adventure of trying to build a small table, and I gave myself three requirements. It has to be cheap, very low height profile for the design, and made from wood. So come with me as I dive into the different designs ideas. My next idea is I wanted to make it more of a circular sand table, and so I got the idea that if I had a top platform and I had it on like this, I just have one cheap stepper motor here, and if I was able to connect a servo, this could have a little arm, and then this could rotate, and then the arm could swing there. This idea kind of worked. I used tin foil, and I laser cutted some grooves into the wood, and then I was able to make some contacts that it would rub on, and then the wires would connect to each of these rings here to transfer the power to the servo motor. And then I would just use a single servo here, and the arm could move there. I used some wire strips there, but when you connect it here, and then you connect it right like this, and then you would have it rotate like this. The problem is this: there's not too much force pushing down at the top right here to make those contacts. So then I got the idea, maybe if I had some retractable pins right here, I could bore in holes down here and have these little pins to go there. But the whole idea of doing this myself is either that, or you're going to have a contact, a slip sleeve. And what this does is it makes it so that your wires can be in that shaft there, and it can rotate. So if I had this shaft right here and I had a slip sleeve on it, the wires wouldn't get tangled if they rotate, and this could go to your servo. But the problem with that is these devices are expensive, and the idea of this whole project is to make it as thin as possible and to make it so that it goes on top of my coffee table. So that's not working. So then my third idea was just using gears instead of this rotor here. And I'm just using two cheap stepper motors here, and this can rotate around the outside perimeter of that center gear, and then if this rotates, then this would rotate the outer guy there, and then this could be a circle, because a circular table I think looks better than a square when you're doing the sand art. So then I got this idea. So if I rotate this, we can rotate the center shaft. We'll rotate it around this way, and then this one will just rotate it in place. So I could start, for example, on the outside diameter, and then rotate that around. Since both of the gears are connected, I would have to counteract the rotation so they would be always in the same place. So as it's rotating, as this one is rotating this way, I would have to rotate this in the opposite direction to make sure that he's always in a fixed position relative to the circle. But I do like this idea. It doesn't require any belts. If that design doesn't really work for you, you can use these stepper motors and use the same principle, but you see we have a free moving shaft. You have to use a different stepper motor, because this has a free moving shaft, when you deactivate that, whereas these smaller ones, it doesn't have a free moving shaft. It's kind of fixed in place when you don't have voltage. So you'd have to upgrade to a more expensive motor.
Okay. So I plugged it in, so the center shaft is fixed in place. Let's see what happens. So if the center shaft is locked in place, as we rotate, this top shaft also will spin because it's also connected by this belt. You can counter that by doing an opposite spin on one of the shafts. Another idea is you disable the shaft and make it freely spin. So what I'm going to do is I'm going to just, like, there's an enable pin, basically. I'm just going to take off the power. So if I take off the power, then it's fixed in space. So I really don't like belts because I had to use some staples and join the belt with some glue, and then you'd also have to have a tensioner maybe in there as well. I just want to use wood gears. So here I just have one right here, one there. The second issue with this design here is actually I had to offset the height of each of these motors. So this new idea, the motors can just be on the same plane. So that's not a issue. This is the new idea. Again, it's going to be just using these cheap stepper motors, and I'm going to have 2 motors, 1 and 2, and I'm going to be using a wooden dowel, and this will give enough distance from the magnet to this shaft here that hopefully it won't be attracted to it, because when it swings, this motor will actually be on this joint here, so the magnet will actually never really go over this point until it kind of goes on an angle right here. But I think it should be okay. So this new idea uses a wooden dowel in the center, and then I'm going to be using each of these are wooden gears and they're made out of wood that is about 3 millimeters thick. You can use the laser cutter to cut that. And so what's going to happen is this is going to be connected to the main shaft. It's going to go through here, and then it's going to be connected to this right here. So this can rotate. And as that rotates, this arm will rotate just like how we have here. It will rotate around the outside diameter. So that's that shaft here. And then what happens is I have a double thick gear in the middle, because I need to have the outside gear connect right here. And then when it's swinging over, it has to be able to go over top of the gear here on motor 2. And so this will be connected here and here. And so this is a free moving gear right here. It's not actually connected to the main shaft. That's why I put it a different color. So you can see the transfer of energy, and that will actually rotate the second shaft there, and I rotate it there. Thinking about putting a wheel bearing right here on the wooden dowel. Again, I'll just be using wood for the entire build mostly. So you can easily pin wood onto a dowel, and it can rotate there. And you can think of different ideas, do lots of different testing. with different components. So that's the main idea so far.
That's my ideas so far. If any of you have some more insight, you can post your ideas in the comments, and I will see you in the next tech repair or tutorial video. And if you haven't, you can consider subscribing, and that would help out. Okay, see you guys later.